Hello students, we're going to do a ray diagram for a curved mirror. So if you do a ray diagram for a curved mirror, whether it is concave or convex, they are done very similarly. There are 3 rays that we're going to draw. You really only need 2, but we're going to do 3. If you do a ray diagram for a flat mirror, like a plain mirror that you would use like in the bathroom or something like that while you're doing your hair, then you only need 2 rays for that one. And that one's very straightforward, and there is a picture of how to do that in your book. So I'm not going to go over one of the flat mirrors, but I am going to do a curved mirror. I'm going to put, once again, the key terms that we're going to use when we're doing reflection problems or ray diagrams. Again, they should start to be making sense to you. And then I will also put up the problem that we're going to draw the ray diagram for. So you may want to pause the video for each of those 2 slides that come up, and then I'll show you how to draw the ray diagram. Okay, so let's do our ray diagram. And so what we have for this particular problem is we have a mirror that has a focal length of about 33 centimeters, and we want to find the image position when there's an object at 93 centimeters in front of the mirror. So what I've done is I've drawn the mirror right here, right? And so I'm writing the mirror on the reflective surface, so this is going to be our concave mirror. And what I'm going to do is get this fancy tool over here, and we'll see if this will roughly work. So it says that our focal length is 33 centimeters, so let's see here, I've got let's see, 10, 20, 30, something like that little mark right there. Let's get rid of that now. So I'm just going to put, this is our focal point, so that would be capital F, and then it says that we've got our object is about 93 centimeters away. So we've got 10, 20, 30, 40, 50, 60, 70, 80, 93 roughly right where that little mark is. I know you can't see that yet. We'll get rid of the ruler. And so this is roughly, that was pretty terrible. Let's draw that again. This is roughly where our object is going to be. So I'll label that P. And so now what we need is really just a couple of rays to figure out where we'll put the object. Of the image rather. So actually what I'm going to do is, just to make this a little bit easier for ourselves, I'm just going to make it a little bit taller, just to make it a little bit easier to draw. I'm going to change the colors just a little bit. We'll just pick this color and we'll draw in our first ray. So the first ray goes parallel. So if we just pick one of the spots, try to pick the tip here, this one goes here. So this will be ray number 1. And then what it will do is it will pass from the mirror through the focal point. We'll see how well that I drew this here, like that. So that will be ray number 1. And then ray number 2, let's pick another color. We'll go through the focal point from that same position on the object right to the mirror like this. So this will be our second ray. And then it will go parallel to the principal axis. And really where these rays intersect, that should be where the object is. Now, the other thing that we can do, just to confirm this, is we can draw in where the center is. Now remember, this was, what was it, 33 centimeters. So we've got our, we'll just slide this over, come on, slide over. We've got 10, 20, 30, 40, 50, 60, it's about 66. So that would be roughly where the center of curvature is. Let's move this out of the way. Here. And if I use one more, let's pick a different color. How about this one? And we go through the center of curvature and then it comes back again. This one doesn't always match up, right? This one would go this direction. That would be the third one, and then it would bounce back parallel to itself over here. You can see it doesn't quite match up. And that will happen with our concave spherical mirrors. It's called a spherical aberration. We don't actually get a nice, clear, crisp image because these rays don't exactly match up over here, so there'll be a little bit of a blur to it. The way that we would fix this, of course, is if we used a parabolic mirror. So we would bend the sides a little bit so that we could get all those rays to focus. So if I just look at those first couple of rays here, you can see that roughly it would go in this direction. So that's where Q would be. So what does that tell us? It tells us that this is where we would find the position of the image. And the image, of course, is inverted. It's also going to be a real image because we have real rays of light that are forming the image. And if we wanted to, we could measure what the height is. This distance right here would be our h prime, and this distance right here would just be h. And you can see, without even measuring, that this distance is a lot smaller, right? So we can say that we have magnification that is going to be less than 1. So this is an example of a ray diagram for a concave mirror, and we got an inverted real image. And depending on where the position of our object is, how we move it back and forth, we can end up getting an inverted and real image, or we can also get a virtual and upright image. If we did take and put this object here, right on the focal point, then there's no image at all, right? It just goes to blur. So you can almost try this with a spoon, although you have to get really, really close. Maybe if you had a big spoon, you could see that you would be upside down, and then when you get closer, you'll switch and you'll be right side up. So give these a try. There's a few more examples of how to draw these ray diagrams. And if you have any questions, just let me know.